So today we're going to talk about Kaggle and how to participate in Kaggle, how to advance, and how to win competitions on Kaggle. The first question I have, do you know what Kaggle is? Like, raise a hand who knows about that? That's good. Have you ever participated in Kaggle? It's quite a lot, to be honest. It's good. It's really good. Nice to see that. So today I'm going to talk a little bit about Kaggle, what kind of platform it is, what kind of people participate in Kaggle, like why do you need it. And then we're going to start with something simple, how to do very first steps in Kaggle, how to make a first submission, basically how to get started participating in Kaggle. And then we're going to go a bit deeper, how you can advance to probably become a Kaggle expert. So you need a little bit of the expertise. And also there will be a couple of tricks to help you advance faster. And the latest section I'll talk about will be about how to win your very first gold medal in Kaggle. And I wouldn't say there is like a shortcut for that, but I'll cover some things that might help you a lot. And I was about to also include another section about my recent competition where we won a gold medal. It's on a Santander customer transaction prediction, but this has grown kind of huge, and I decided not to do it this time, but probably next time maybe. We'll see. Okay, let's start. So Kaggle is basically a platform for data scientists and machine learners. People basically go into the platform to mostly have fun, to learn a lot of new things, to gain some knowledge, and to meet new people, to share the experience. And for now, there are about like 1 million registered users, and that's quite a lot, to be honest. And about 100,000 people actively participate in Kaggle. And there are a couple of tiers. It's called like grandmasters and masters and experts, and we'll talk about it a little bit later. But basically, there are about 50,000 people who just got started. About 50,000, pretty much the same people who frequently contribute. 4,000 experts, 1,000 masters, and about 140 grandmasters these days. So Kaggle is a platform, and there are many things you can do, and it is well known for, first of all, its Kaggle kernels. It's matured quite a bit lately and became very good, so you can run your cloud-based scripts on Python, on R. You can do pretty much everything. There is a very strong GPU. You can trade your classifiers for a long time. So I would say if you want to play a bit with different data sets, that's like a perfect place to do. And so there are Kaggle data sets, a very huge set of them placed already in Kaggle, and you also can add any of the new data like anytime you want and play with it and share your data for other people to play with it. There is also Kaggle Learn platform. It's honestly, I've never used it, but it's for people who want to get some sort of the education and get started with the very basic knowledge on what AI is, what data science is. And there is also jobs board. You can post your jobs opportunities, and you can also apply for some of them. It is cool because it's very focused exactly for data scientists and machine learners. So if you are one of them, I guess you are, so it's a nice place to look for a job. So this is how medals work on Kaggle. So every competition, it has sort of rankings, and people who participate in Kaggle, they may have a chance to win a medal. It may be a bronze medal, a silver medal, and a gold one. And recently, I wouldn't say that there are many competitions with less than 1,000 teams. lately it's like 2,000, 3,000 easily, and I would say 3,000 people participating in average these days. So it means like 10% is to get to the bronze, 5% is for the silver, and about top 10 people plus every person, each 500 teams is for the gold medal. But you also can learn medals for the kernels and discussions. And this is how you do it for kernels. And for discussions, it's quite similar, to be honest. You need to get up votes, and that's basically it. So it's very easy to get started. You just need to register, right? Not much to do. But to be a contributor, it's pretty easy as well. You just need to verify yourself. You need to make a comment. You need to make an upvote. You need to do at least one submission. Not difficult, to be honest. But to become an expert, it's a bit more tricky, I have to say. And you need, like for the competitions master expert, you need to get at least 2 bronze medals, which is not as easy as it seems, first of all. But as you can see, you can also get the discussions. You got the discussions expert or the kernels expert. If you create a couple of kernels or make a couple of discussions that other people upload, it is very, very useful as well. And there's also a master tier, which is a little bit more tricky than expert. So you need not just bronze medals, but you need 2 silver medals and 1 gold medal for the competitions. And pretty similar options about the kernels and discussions. And there is the highest tier is Grandmaster on Kaggle. You need at least 5 gold medals, and one of them has to be a solid gold medal. So in Kaggle, you can create teams. You can make a team or join some of them, and or it's up to you. You can practice alone on Kaggle. But the highest tier, and it takes usually takes years for people to get there. I know one person who got it in about 5-6 months, and I think it was the fastest way. And now the slide about me, you can see. So my name is Sergey Shilin. I'm on Kaggle, and I'm currently a Kaggle master. I know it's not very high, but still something. And today I'm going to share my experience with you, how to get there and how to advance even more. So there are competitions in Kaggle, and there are also like of different types. And the first thing you probably want to do is to get started. So there are exactly competitions for that. They call it getting started competitions. And there are also playground competitions, which are quite similar to the previous one. Probably just a little bit more interesting. The rest of the competition, it's basically either featured or research and recruitment. And those are either for jobs or for the money prize. And the money prize in Kaggle, it is sometimes a lot and sometimes not very, but it's up to you to choose. I know like last year there was one competition with a total prize of $1,200,000, which is fairly good. And like usually top 5 teams or top 3 teams, they share the money in some equity. But for this competition specifically, it was pretty much everything for the first place. So the first place won about $1 million. So this happens sometimes, not every time, but yeah. So this is how it looks. So you have a list of competitions, and you basically choose whatever you like the most. There are some tags you can see, like NLP, text data, news agencies, finance. So I usually go to the list like time to time, not very often, and I pick the one I'm very interested in. And I think that's the key number one to get to the proper direction. So you choose exactly what you like to do. Because if you just choose everything, you'll be very easily disappointed. And it's probably not the first experience you want to get. So how to get started on Kaggle? First of all, what I would recommend is to choose, like if you don't know anything about data science, about classifiers, clusterization, you should probably read something on that, I guess. But there is a playground competition, and one of them is like Titanic. I'll show later this one. It's fairly simple. You have you need to predict whether the person on the Titanic will die or not, or will survive. And it's based. You have features like the age, gender. You have what else? The location on the Titanic, and you need to understand how exactly it correlates with the chance of survival. So competitions like that are fairly simple, and it's very nice one to start with. So this is what I would suggest to do if you've never done anything like that before. So the second thing I would suggest is to pick the one you are most interested in. So you go to the list. It updates, like, I don't know, very frequently. They have a new competition every 10 days, maybe 2 weeks. So you get updates on the email, and you can basically double check what kind of data they have, what the conditions, what the task is, and what you need to produce, what kind of result it is, what kind of metrics they have. So that's what I usually do. I decide if it works to investigate, at least to download the data and to look at it. If not, I'd probably keep it for another one. So the other thing you need to keep in mind is when you go to platforms like that, the first thing you want to do is to aim to learn new things, aim to gain new knowledge, but not to win the money. Because if you come to competitions to win, this will unlikely happen, to be honest, because there are many other people who do the same. And yes, just be ready to fail a lot. This is exactly what's going to happen. And Kaggle kernels and forums is exactly what you can use, and exactly what can help you a lot to advance a little bit. So you can read about different solutions, different approaches of other people, how they solve this problem, how they approach the problems in general. You can find a lot on the kernels and forums, to be honest. And this is what helped me to get started and to advance further. So those are competitions are very nice to start with. And so Titanic I mentioned. Digit recognizer is mostly for computer vision. So you have the data set with 1 to 3 handwritten digits. You need to classify those. Another one is house prices competition. I've never tried that, to be honest, but I think it's worth trying. So as I mentioned, you should aim to learn, but not to win. And first of all, what you can start with is to pick for your task, you can pick the very simple algorithm, the very primitive model, like logistic regression, probably random forest, or something like that, just to see how it works, just to try to apply it to your data set and understand like what you can get from it, what kind of a score you can obtain. And you can play around those simple models, and it's going to be enough for the first time. And it's going to be something at the very beginning. So the one thing that can help you is if you try to visualize your data, you can find many interesting things. And sometimes they discover, I don't know, some correlations or some very interesting behaviors in your data. So it worth to take a look. So I usually use some libraries like Matplotlib or Seaborn, but there are many others. Just feel free to take one or many and try something, like try to visualize your data. Metrics and loss functions, that the other thing you could probably take a look and play around. There are different ones, and some of them work better for your exact competition, some of them not really. So worth taking a look. Feature engineering, yes, I think in the very beginning it's really interesting to try. So you can generate more data from what you have at the moment. You can remove some features, you can combine them somehow. So basically, you can play with your features in a way to get more performance of your model. And sometimes, like, there are many competitions that you can win exactly doing feature engineering only. So check your interactions, how your features interact with the target, and also correlation matrix. You can see what kind of correlations you have. And also, like, it works to make as many submissions as you can at the very beginning, because simply you will have differences in the local score if you do like cross-validation, and in the public score, and also in the private score. So there are different leaderboards in Kaggle in the competition. So you have the public one. It is what you can see all the time. It is based on some portion of your data, and the private one will be available to you only after the end of the competition. But local score and the public score, it's what you can play all the time with to see the differences, to see how you can adjust a little bit your local score to get some improvements in the public score. But I would say that the rule of thumb is usually use 90% of your local score, and sometimes like 10%, I wouldn't say more than that, of your public score to make a decision if your model is good or not. So trust your local score. How to advance on Kaggle? First of all, it's very important to mention, just be ready to spend more time. It takes more time. It seems easier than it is actually. And this is just it. I don't know, at the beginning it took me about like an hour a day, 2 hours maybe. If you want to advance on Kaggle, it's gonna take more and more time. And sometimes, like, if you're very into the competition, it takes a lot. It takes 3-4 hours maybe a day. And I know, like, people start competing at the very beginning of the competition. Sometimes, not all of them, I'm saying, but some of the people, and they do it like the competition lasts for about 2 months. So they span about 4 days a day, or 4 hours a day for 2 months. And of course, companies win because of that. People spend a lot of time on the competition trying to find the best approach. Yes, and knowledge comes with practice. Basically, that correlates with what I said before. Like, if you want to advance, like, once you're done with your simple models, I would suggest to play with more complex ones, like gradient boosting, for example, is XGBoost, Light, GBM, and CutBoost. Those are pretty advanced algorithms, and I would say these days, if you go to a fairly simple competition with very usual data, like numerical data, that's what people usually do. They use those algorithms and kind of ensemble them and get to the top. You can probably try some neural networks and deep neural networks. Sometimes, not very often though, it depends on the competition. You can try some convolutional networks and NLP approach maybe, why not? Or reinforcement learning. you never know. It's very good to try new things, to be honest, and make as many submissions as you can just to see, because sometimes when you, like at the moment, you don't have very much of experience, you never know what will work exactly. And sometimes it just magically works. And you probably should start exploring samples. Like once you start competing on Kaggle, and once you get closer to the top, like people win a lot because of the ensembles. And like a couple of last weeks, that's what people do. They just ensemble all of the solutions to get a better approach, a better performing model. So a couple of tips I have here. It's some of them work, some of them do not always, but you can try. It's one of them is to fine-tune your hyperparameters. Once you get your fairly good model, you can try to fine-tune it to see if a little bit different variation will play a bit better, maybe. So two things you can try here is to do a grid search to find the most optimal parameters. The one I usually do is Bayesian optimization. It just works faster. You don't need to go through all the parameters. It somehow finds the global optima faster. A couple of things for the generalization. So you basically want your model to be as generalized as possible, so you can play a little bit with your models and I don't know, you do data augmentation, you play with the regularization, you apply batch normalization and the dropout if it's about the neural networks sometimes, why not? Maybe you can try better train and test split. In this case, you may see a little bit different difference on the score, and sometimes it reflects very well on the public leaderboard. Yeah, try advanced statistics. Why not? Like you never know what works. Something, I don't know. Like the only thing comes to my mind, for example, is maybe probability calibration. If you use like logistic regressions and binary classification, you can play a little bit and help sometimes. So those things, they're not very obvious, but some of them may work, and it's worth trying different approaches. PCA, I wouldn't say it helps all the time, but sometimes it helps a lot when you have a very, very big data set and it doesn't fit into memory. So it does not improve your score, but it helps you make a prototype much faster. Once you get like a score, once you see that your score is improved on the prototype, you can probably rent some resources in the cloud and make the whole solution running without PCA. Noise reduction helps quite a bit sometimes. It depends on the task, as well as the data processing, missing data processing. And here we go to the win the first gold medal section. So those are things that usually help me to approach the top positions better. And I would say the most important of them is to structure your project, because once you start competing, it is very easy to get lost. And the more submissions you have, the more lost you will be, because eventually you'll need to sort of combine those submissions in a particular way. Like, especially if you want to ensemble them at the very end, you will want to know what kind of different submissions to take into account, like what kind of weights you can set to those particular submissions. Yeah, spend a lot of time is another technique. That's what I'm saying. It's probably one of the most important things as well. There are things they're called leaks, data leaks. And there are different variations of them. I'll cover it a bit later. And another important thing is to team up with other people. I would say it's very hard to get a gold medal alone. And if you just get started, try to team up with other people because they have different approaches, and you combine your solutions, you'll most likely get a better one. And I don't know, even like for me, if I try to participate in a competition and I know it's very interesting, I usually try to invite like one of my friends to that, so we can just share the ideas. Even if it doesn't work, it is much better. So you can think more, you can just share your thoughts. It's very hard to do that alone, to be honest. At least for me, I don't know. I know there are many people who participate alone and it works just perfectly for them, but not for me, to be honest, and not for many people. So that's what I would suggest to do. And there is also, like, almost always there is a portion of luck that you need to get to become one of the top people in the leaderboard. It's fairly hard, to be honest, sometimes. And yeah, I'll talk a bit on that later. So there are 3 very, very simple steps to success, and one of them is to work hard. It's not difficult to guess the other one. It's work harder. And the last, you can guess what's gonna be. Yeah, this is it. Basically, that's the only thing you need. You need to work really hard. You need to understand that it takes time. Sometimes like half of the day, and if you work, you come home after the work and you play it like you do it at home. It's a bit tricky. Sometimes you work on weekends. Yeah, it's not for all of us, you know. So my favorite structure of the projects, it is like that. You can see on the screen. You have the folder with the data. You have the folder with the model. You have your notebooks, like your Python notebooks, you know. You can make some observations. And there's a predictions folder. So the idea is that every step you make to create your submission, you need to store it. You need to save your code somehow, because if your submission wins, you will need to prove and recreate the steps to create the submission. So what I do, like, I have a script, like every script that generates my submission, it will be saved into the models like that. So exactly the code to create a submission. And there are also predictions. Those are basically the submission for the test set. And I do have one for the train set in order I will want, like, if I want to make some sort of stacking. So if I play with ensembling the solutions, I'll need train predictions as well. This is how it's gonna look like probably at the very beginning. Sometimes, not all the time, to be honest. Yeah, let me move it a bit. Nah. I usually use a spreadsheet. It works. I'm sure there are many other solutions that are nicer than that, but it does a job, you know. You have the submissions, and the idea is that you just keep track of everything you do. So you have sort of a description, you have your scores. Usually it's a local cross-validation score plus like the public leaderboard score plus the private. And when it comes to the point when you need to make an ensemble of the solutions, you may take a look and decide which of them to include or to exclude. For example, here you can see some red submissions. That means those are broken, and I want to know which of them not to take into account eventually, so I just exclude it. But I still have it in the table, so I know exactly what I will not include. Let me see. No, it's frozen. No, it's not. So a couple of notes here. So as I mentioned, you need to store everything. It's very important if you want to try to win something. Be very careful with the row orders in your submissions, because sometimes if you don't fix if you split your data like you do, for example, apply stratified k-fold method, and if you don't fix random state, it will produce different splits all the time. And for different submissions, it will be different data. And once you get to the point you want to stack them all, it will be like all different rows. And you just cannot do anything about that. It will be too late. So make sure you do everything like that at the very beginning. It is important. And yes, spend a lot of time. For me, it's usually like once I become a bit serious about the competition, it takes about 3 to 4 hours per day. It is a bit more for some other people. For the rest, it's probably enough to, I don't know, to join in the very last week of the competition, spend just a little bit of time, but you know, that comes with practice and it's not very easy to do. But when you just get started, you basically want to spend a lot of time. Models are constantly training. It means like you always have new ideas and you always want to test them all. So make sure that at least one model is training at the moment. The more the better. Sometimes people rent resources like go to the Google Cloud or I don't know, Amazon, and they buy a server, or they, I don't know, rent GPU resources, and they train probably like 10, 20 different models at a time. It saves you a lot of time. It costs money, but it saves you a lot of time. Like in case you want to try, for example, one model but with different hyperparameters. You never know which of them work. You just try, and it's going to be much faster. And as I mentioned, average competition lasts about 2 months. So that's a lot of time. It's not for that, for all of us, but for some. Another thing you need to keep in mind is to start looking into ensembling and how to ensemble your solutions and your submissions properly. The very first and the very obvious, well, probably not very obvious thing is that ensembling weak models work the best. That's basically the idea of ensembling. You take not very strong models, like probably logistic regression and like a couple of neural networks, and you try to combine the predictions, like you take the average over them, or in some other way, you can play with the weights, you can try different parameters, and that usually works the best. Sometimes when it gets closer to the top, you want to probably ensemble strong models as well. I'm not saying it works always, but sometimes it does. You want to try blending and stacking. Those are basically methods to ensemble your solutions. And sometimes you also mix your features into like some levels of your ensemble. This is one of the examples how it may look. Not the most, like, not the best probably, but I don't even know if it's the one who won a competition, but like there are many solutions like that who basically try many algorithms, many models. The very first step, like XGBoost, random forest, neural networks, we combine them all. You have some output with like a set of features, and you try the other layer. And you probably want to blend your solutions after all. Yeah, people do that too. At least you need to understand why they do it and what kind of a result it can be. This is one, like the picture from the latest competition I was solving. It's basically, we have different models, and sometimes before you put them into the ensemble, you want to see what importance they have, like different models, different predictions, how important they are. And for example, the first one is a cat boost approach. You can see it's according to the feature importance. It's the most important. The other one, it's much less stronger. It's a neural network, but surprisingly, it's the second important feature, the second important model. So sometimes it works, they kind of look to see the picture, like what models play a bigger role in your ensemble. Leaks are very interesting things in data and in competitions in general. Like, there are a couple of different types of leaks. Probably the most famous is a target leak. The other one, about target leak, I'll talk a bit later in the next slide. The other one is a train validation leakage. It is, surprisingly, when you split your data and you validate, you have a very, very nice result, like a very high accuracy, and you try to understand why, and it looks like perfect. But at some point, like when you go a bit deeper and investigate it, it turns out that you mix your trained data into the validation somehow. And that's why you get a high accuracy for the other metric. And very rarely though, but still sometimes, test target is exposed in external resources. It means, I remember like one competition at least, when the exact test data was found on GitHub. And people just took this data and put it into the train and trained everything and got like 1.00 accuracy. And after that, the competition was closed, obviously, but like it happens sometimes, you know? Like sometimes they don't close the competition and this is the way to win. Yeah, a bit tricky. I know. So about the target leakage, those are very like simple examples, I guess. So you have a target basically, and you also have another feature in your data, which is very highly correlated with the target. Sometimes it is like you have to predict the annual salary, but you have a column in the training set which is called standardized salary. It is still the same thing, but it's just preprocessed. So it happens. It happens because people who put your data, these data, they do not care much about what kind of features they have, or probably they just forgot it. You know, it happens. Or another example, if you need to predict if a person took antibiotics, and you have another, by any chance, you have another column in your data which is called pneumonia, and this is surprisingly very highly correlated. You know. About teaming up with proper people. This is a very nice slide, to be honest. It happened last time on the very last competition. I had a couple of teams that sent a request to team up. So the first one was the people who decided to team up eventually, but the other one was a team very insisting on teaming up with them. And I was like, should I do it or not? Eventually, after the competition ended, this team got banned, surprisingly. So it means you need to be very careful about choosing your teammates. Sometimes, like if you probably don't know the person too well, you should probably play alone, or I don't know, find another team. But basically, the higher you get, the more requests to team up you will get, or probably the more you want to join some other team, because basically increases the chances to win. It becomes very intense in the very last week because all the people team up and they produce better solutions. And about getting lucky, it's do we still have time, by the way? So, okay, a little bit, almost done. You need to do random walks sometimes instead of fine tuning because you never know which idea works best, and sometimes you just throw a stone like somewhere, and it works. The idea is basically try as much as you can, like different solutions, different approaches. You test as many crazy ideas as you can, the same thing. And sometimes, like first 200 teams, they're separated by the third decimal, and this is nothing. You can just like win this decimal and get up to 100 positions like easily. This is just a matter of luck, basically. And sometimes there are shakeups in the public and private leaderboard. Don't be surprised, it happens. It's very sad when you are into top 5 teams and after they open the private leaderboard, you are like 100 something or probably 1000 something. Happens all the time. There's a bonus section. I have a question. Let's see how involved you are. So we have a set of true labels and we have predicted labels. And as you can see, there is a difference in 1 digit, right? Oh, I'm sorry, I should have done it. So what kind of the loss you'll get? You saw it? Yeah, okay. You'll get a very high loss. Surprising, right? It's just the difference in 1 digit. Why would you? Another question. You try to calibrate it a little bit and you clip your predictions, like you kind of smooth it a little bit. So those are not 0 and 1s anymore. Those are like 0, 0.5 and 0.95. So what kind of a loss you'll get in this case? Anyone? Any ideas? It's gonna be 10 times less. This is probably what you want to get. And it is true about the log loss, but there are other tricks like that you need to take care of. And basically, a very simple trick improves your score like 10 times. Another thing is have like not a very common one, but it happens sometimes. You have different distributions on your sets. What are you gonna do? Any ideas? Anybody? I'm not saying I have a solution for that, but there are a couple of things you can try. I don't know, probably to make your model as general as possible. This is like, it happens very rarely, to be honest. You will unlikely see the picture like that. But I want to mention that it happened in the last competitions to me once. And the reason was that in the test set, there was a synthetic data mixed into that. So you had about 100,000 rows in your test data, and about half of them was synthetic. And like once you got this, which is very visible in the picture, you just you find this synthetic data, you remove it, and it's gonna be similar. And yeah, tricks like that work sometimes. Sometimes you have unbalanced classes, and you may say that the accuracy is the perfect metric, and you can just see how it works, and it works pretty good, but it's not the solution, to be honest. As you can see, other metrics, they show different things. Or another case, one of the last probably, we have a feature which, like with a very, very weird distribution. Like, do you have solutions to that? How to solve it? How to train a model on that? Any ideas? I don't know, to be honest. But like one thing I would probably do is I would maybe split this peak of data and train a different model on it. So you have like you take all the feature less than, I don't know, 5, and you train a different model on it, and take another model with the feature more than 5. Who knows? Maybe work. It happened one time. I don't remember if it worked exactly, but it was a different approach. still something. And to sum up, like just practice, practice, and practice. The knowledge comes with practice, and you need to spend a lot of time again. Try simple models first of all, then improve it, tune the hyperparameters, try more complex models after that. As I mentioned, project structure is very important. Keep track of everything you do, of every submission you make, like just leave a description, tag it with different words. It will help a lot eventually. Read kernels and forums, see what other people do, what kind of notes they make. There are many things happening in the forums, and this can help a lot to you as well. And don't hesitate to try crazy ideas, because sometimes it may work even better, like unexpectedly. Yeah, that's pretty much it. If you have any questions, ask now. You can contact me by LinkedIn, I think. But yeah, that's it.